Fabric deployments rarely start with code. They start with infrastructure choices. Cloud, hybrid, and on-premises models each change the balance between scalability, control, cost, and operational responsibility. In this topic, we'll connect those trade-offs to real enterprise architecture decisions. So far, you've seen Fabric's architecture, transaction flow, privacy model, chain code, data design, endorsement, and application integration. Now we shift from building solutions to running them, where components live, who owns them, and how operations stay reliable. At its core, Fabric deployment is a trust design problem. The ownership of peers, orderers, CAs, applications, and backups affects more than performance. It shapes security, resilience, governance, cost, and whether the network is truly decentralized. Before choosing cloud, hybrid, or on-premises, treat deployment as a requirements decision, not a preference decision. Start with compliance, where data may live, how audits work, and which controls apply. Then assess operational readiness, including automation, Kubernetes skills, monitoring, and incident response. Clarify who owns each component, from peers and orderers to CAs and gateways. Finally, validate connectivity, latency, bandwidth, DNS, firewalls, and partner access. The best deployment is the one your organization can govern and operate reliably. Fabric infrastructure has 4 connected layers. The runtime is the blockchain system itself: peers, orderers, CAs, chain code, and state databases. Around it are platform services that make it operable, such as ingress, DNS, certificates, secrets, monitoring, backup, and CI/CD. Above that are gateways, APIs, events, and integrations that applications use. Across everything sits governance, identity, policy, access, lifecycle, and operational control. Deployment models differ mainly in who owns and runs each layer. Cloud deployment combines Fabric's trust boundaries with managed cloud building blocks. Kubernetes handles scheduling, scaling, and upgrades. Storage protects ledgers, CouchDB state, orderer data, logs, and backups. Load balancers and ingress expose endpoints without opening everything to the public internet. The design discipline is isolation. Private networks, separate organization namespaces or node pools, governed certificates, IAM, and security baselines. For production, include multi-region planning, so resilience is designed in from the start. A cloud deployment is more than Fabric containers running on virtual machines. Use the cloud as a managed operating environment around Fabric. Keep peers and orderers on private networks, select storage for latency, IOPS, encryption, snapshots, and recovery, and connect certificate services without weakening MSP responsibilities. Then, automate the environment with infrastructure as code: clusters, namespaces, DNS, firewall rules, and secrets. The goal is repeatable operations with less exposure, while Fabric governance remains intact. Multi-region Fabric design is a trade-off, not a checkbox. Place peers near the applications and organizations that need endorsements, or transaction latency can rise quickly. Treat ordering nodes differently. Quorum must survive regional failures, but wide area links can slow consensus. Replicate certificates, backups, configuration, observability data, event checkpoints, and state database recovery assets before an outage happens. Most importantly, test failover. High availability only exists when recovery actually works. Hybrid deployments let each consortium member run where it makes operational sense. One organization may use cloud peers for elasticity and managed services, while another keeps peers and applications inside its own data center for control or compliance. The challenge is usually not Fabric itself, but the connections around it: VPNs, routing, DNS, firewalls, and certificate endpoints. Success depends on clear ownership agreements for uptime, patching, certificate rotation, monitoring, and incident response. For hybrid Fabric, connectivity must be private, predictable, and tightly controlled. Peers, orderers, CAs, applications, and monitoring tools should resolve stable internal names, even when they span cloud and on-premises networks. Use split-horizon DNS and coordinated routing so traffic follows trusted paths, not the public internet. Lock down the required ports for gossip, ordering, enrollment, gateway calls, and metrics. Then monitor latency, packet loss, link health, and certificate expiry continuously. Hybrid operations fail when ownership is assumed instead of documented. Every component needs a named owner, operator, backup contact, and escalation path. That includes peers, orderers, CAs, databases, load balancers, and monitoring tools. The same clarity is needed for patching, backups, incidents, certificate renewal, upgrades, and compliance evidence. The goal is not identical infrastructure across organizations. It is shared standards, clear accountability, and governance agreements that match how the network actually runs. In an on-premises pattern, Fabric runs inside the organization's own data center, using internal compute, storage, networking, security controls, and identity systems. This gives maximum control over data locality and compliance, but it also shifts responsibility to the operations team. They must manage PKI integration, MSP processes, persistent ledger storage, CouchDB performance, backups, monitoring, and failure recovery. The platform may be Kubernetes, virtual machines, bare metal, or an enterprise container stack. Restricted Fabric environments change one major assumption. Nothing should depend on direct internet access. Every artifact needs a trusted path. Acquire it, scan it, approve it, import it, and deploy it from internal repositories. Certificates need the same independence, with internal issuance, revocation, and renewal. Patching becomes a governance process, not a download. Backup, monitoring, and recovery must also work when cloud services are unavailable. Watch closely for dependency drift and expired certificates. Most deployment failures come from governance and operations, not Fabric itself. Watch for 4 warning signs: one party controlling shared infrastructure, unclear ownership of critical assets, uneven security standards, and manual processes that let channels multiply unchecked. Address them early with shared responsibility, clear runbooks, automation, and regular review. Deployment architecture is the bridge between Fabric's technical design and enterprise reality. Cloud gives speed and managed services. Hybrid fits mixed organizations but requires coordination. On-premises gives control with higher operational responsibility. Next, we'll go deeper into Kubernetes, multi-cloud, CI/CD, security, scaling, monitoring, backup, and recovery.